Hi there and welcome to our next video on specific heat capacity. In this video we're going to be looking at what specific heat capacity is. We're going to be having a look at the formula which is used. We're going to have a look at some of the states of matters which are involved in this, and we're going to have a look at some examples to finish off. So first of all, specific heat capacity of a substance is the energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. So the energy that is put in to raise the temperature of 1 kilogram, this is the amount, by 1 degree. So we want to increase this amount by 1 degree Celsius. The higher the specific heat capacity, the more energy the object has in its thermal energy store. So the higher the specific heat capacity, the more energy which is being put in and the more energy it has in its store. Okay, so putting this into a formula, the definition we've seen is the energy associated with temperature and warmth. So some examples might be a fire, the sun. Nearly everything has thermal energy in it. Some of them has more than others and some of them has less than others. So the equation over here, we have the thermal energy is the mass multiplied by the specific heat capacity multiplied by the change in temperature. So we have the SHC is the mass multiplied by the SHC, so this is the thermal energy, and multiplied by delta T. This triangle means change in, so it means change in T, which is the temperature. Okay, so the warmer an object is, the higher energy of the particles are, and we're going to have a look at that now. So over here we have solids, liquids and gases. From a solid, when we're adding in energy, we are making the particles vibrate even more. So when we're making the particles vibrate even more, then those particles in a solid start to lose their shape, and when they start to lose their shape, they turn into a liquid. Liquid is just like a solid, but they can flow from place to place. They are vibrating faster and they don't have a shape. So when you add energy from a solid to a liquid, it turns into a liquid. For example, you have a solid, you're burning the solid and it eventually turns into a liquid. For example, you have butter. If you burn butter on a pan, then you have the butter melting into a liquid. You are putting in heat energy to turn the butter, which is a solid, into a liquid. Now once the butter has turned into a liquid, it is bubbling, it is still getting warmer, the energy is still being inputted into it. Now where will it go next? Well, it will just evaporate and turn into a gas, because the heat energy is so violent now, it is being put in so much, it will turn into a gas and it will just evaporate off somewhere with even more kinetic energy. But if we're going the other way and we are removing energy from these states of matter, so from gas we're removing energy, so we are taking back the kinetic energy that they have, we're taking back the heat energy that they have, and we are making it condense back into a liquid. And then from a liquid, if we take some more energy back, we are making it go to a solid, we are freezing it. So we are taking away its thermal energy. So for example, if you're boiling a liquid onto on a stove and then you put it into a box and put it in the freezer, well, that liquid's going to turn into ice after a while, because the energy is being taken out of it. So that's what happens when you're putting in energy and you're taking out energy. So now we're going to have a look at some examples. So The first one says calculate the energy required to increase the temperature of 2 kilograms of water from 20 degrees Celsius to 100 degrees Celsius. The specific heat capacity of water is 4,200 joules per kilogram per degree Celsius. Okay, so we need the formula first. So we've seen that the thermal energy is the mass multiplied by the specific heat capacity multiplied by the change in temperature. So this is step 1. You've got your formula. Step 2, we input in our numbers. So we need to find out the thermal energy. This equals the mass. We're given the mass over here, which is 2 kilograms, multiplied by the specific heat capacity over here. Normally the specific heat capacity of water is 4,200 joules, but you will be told this in an exam. So we have 4,200 joules multiplied by the change in temperature. So we know that it goes from 2,000 degrees per Celsius to 100 degrees Celsius. So our step 3 would be to do 100 degrees Celsius subtract 20 degrees Celsius. This would give us an answer of 80 degrees Celsius, and that over here is the change in temperature. So what we do, we multiply this by 80 degrees Celsius, and now we have our full complete equation that we can just type it into the calculator. So we do 2 multiplied by 4,200 multiplied by 80. This would give us an answer of 672,000 joules. 672,000 joules. That is our final answer, but we can convert that into kilojoules. We divide by 1,000, so it would be 672 kilojoules, and that is also acceptable. Okay, next set of questions. Water has a specific heat capacity of 4,200 joules per kilograms per degree Celsius. Calculate the energy change when the mass is 10 kilograms and the change in temperature is 4 degrees. So we write down our equation, which is the mass multiplied by the SHC multiplied by the delta T. The mass we're given is 10 kilograms. It's in the right units. We do 10 multiplied by the SHC, which is 4,200, multiplied by the change in temperature, which we're given is 4 degrees Celsius. Now we have our full and complete equation, so we can just type this into our calculator. 10 times 4,200 times 4. This will give us an answer of 168,000 joules. We can convert this, however, into kilojoules. We divide by 1,000, 168 kilojoules. And both of those answers are acceptable. Okay, this question now. Copper has a specific heat capacity of 390 joules per kg per degree Celsius. Calculate the energy change when the mass is 20,000 grams and the change in temperature is 2 degrees Celsius. So over here we would need to do a bit of conversions. Let's write down our equation. We have the mass multiplied by the SHC multiplied by the change in temperature. The mass we're given is 20,000 grams, but we need to convert this. So we do 20,000. So this is in grams. To get to kilograms, what we do, we divide by 1,000, which is 20 kilograms. So we've done step 1. This is in the correct units, and 2 degrees is in the correct units as well. So now we can just write it down. We have 20 kilograms multiplied by the specific heat capacity, which is 390, multiplied by our change in temperature, which is 2 degrees. Now we have our full equation, we can just type this into the calculator. 20 multiplied by 390 multiplied by 2. This will give us an answer of 15,600 joules. That is our answer, or we can convert it into kilojoules, which would be 15.6 kilojoules. In the description box below, there's a link to a quiz which you can have a go at. In our next video, we're going to be looking at some exam questions to do with specific heat capacity. But that is it for this video. Thanks for watching. I hope you liked it. And one last thing, please subscribe, hit the like button and the notification bell.